Okay, today it's going to be a little bit longer because there's a lot to explain here. I need to show you, let me shrink this down. We need to go to our agenda. So the next time we have class, there is going to be a test. So it's important that you can describe the basic structure of an atom, meaning you can use your periodic table that you should have printed off at home and be able to use those periodic table squares in order to figure out the number of protons, neutrons, and electrons that are in that atom. That's the basic structure. And knowing where to put those protons and neutrons in an atom model and where to put the electrons. You should also be able to explain and calculate the mass of an atom, knowing that the mass is in the nucleus and that the protons and neutrons are in the nucleus. So those are the two things that you add together to get the mass of the atom. And the last is being able to identify different types of atoms using the periodic table. So knowing that, you look at the proton number in an atom, and whatever that proton number is, you can then use the periodic table to find that atom and tell me what the element is. A few housekeeping things. Make sure that you have turned in your summary notes. Those are images and pictures that you should have taken for the reading of the summaries that were in your journal and uploaded those. I'm about to put those into into Skyward. Also, there was a worksheet called Counting Atomic Particles that we did last week. That was in something called Teacher Made, and so you did that as well. If you were actually in person, you had a paper worksheet for that. So today you're going to need to take out your periodic table, which is this guy right here, and you are also going to need your journal as we're going to take some notes. So the first thing I'm going to have you do is let's do our warm-up here. Here's our warm-up. What is different about each element drawn above? So I'm going to take a look at these pictures and see what is different about each of those elements. And then I want you to tell me and analyze the image above. Is this the same element or are they different elements? And if so, what are the names of these elements? I'm going to give you some time to think. So now that we have thought, you should have seen that the center or the nucleus, meaning the mass, there's different number of neutrons in each of these element models. And when I look at this, this is considered the same elements because remember, elements are identified by their number of protons. So there's one proton here, one proton here, and one proton here. And if you look on your periodic table, and I'm going to try to hold this up, if we look, the atomic number is that big number above the letter. You find the number 1 for one proton, and that tells us this is the hydrogen atom. So they are all pictures of hydrogen. This is just hydrogen with a mass of 1, hydrogen with a mass of 2, and hydrogen with a mass of 3. Okay, so if protons identify the element, if we take a look here, we can count our protons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 protons. So I would find atomic number 11 with the big 11 over the letter. And if you find that, that is the element in A, which is sodium. So as a review from last class, the atomic number, that number that is above the letter, is going to tell us two things about the atom. It's going to tell us the number of protons it has. It's also going to tell us the number of electrons. That's 8. Atomic number, protons, and electrons are all the same number. So in fluorine, there's 9 protons and 9 electrons. For the mass, you will always be given the mass number, but we're going to subtract the atomic number from it, and that's going to give us neutrons. Now, this is a decimal number. In any of your problems, I'm going to be giving the mass number that's a whole number because this is an average. Just like when you take your average in school, in your classes, sometimes you have a 96.2 or a 97.3. This is an average because some elements of fluorine have 9 neutrons and some have 10. So this helps us figure out what those are. So we went over a few more and we looked here, and for example in this one it's hard to see because we have a clump in our nucleus to figure out how many protons exactly we have. And with 8th man we know that protons and electrons are the same, so if I count all these electrons I'm going to see that there's 13. So I could go find atomic number 13, and that is actually aluminum. So we can use our protons to identify, but knowing 8 here that electrons and protons are the same, we can also identify there. If we look at this particular example, we don't know which ones are protons. We know that they're in the nucleus. but they're both the same. We have 2 of one and 2 of the other, so we can assume that, oh, and there's 2 electrons, that this is atomic number 2, and when we look on our periodic table, this is helium. Okay, I'd like you to go into Google Classroom now, and in Google Classroom, I'd like you to take and pause this video, and I'd like you to slide these boxes to where they are, where they go in order to tell us about protons, neutrons, and electrons, their location, charge, and size. You can look back at your notes in the Atoms Interactive Notebook to help you do this. So hit pause and go ahead and take care of that. Okay, now that you have dragged those boxes over and you've turned it in, if you take a look at it, protons and neutrons are both found in the nucleus of the atom, and our electrons are in the electron cloud. Our protons have a positive charge, neutrons are neutral, and electrons are negative. And then we have 1 AMU. So to find the mass in terms of size, 1 AMU for our protons and neutrons, and our electrons are really tiny. It takes 2,000 electrons to equal the mass of 1 proton or 1 neutron. So we don't even count those in our mass size. Okay, the next thing we're going to do now, we're going to talk about this model here. I've got a tennis ball showing that this is going to represent our nucleus. And our nucleus, inside, we have protons and neutrons. Electrons circle in the electron cloud, and they go all the way around randomly. They don't go in one path like we do around our sun and like the solar system. They go all the way around, and we're going to learn about these different regions. We're going to learn the first 3 regions, or what we call energy levels, or shells, or orbitals. So the ones closest, so if this is the nucleus, the one closest that these electrons could be going to is called level 1. And the one that's a little bit further out is called level 2, and the last one is level 3. Now, a guy named Niels Bohr, he was a scientist, knew that it would be really hard to show these going all over the place within that region a certain distance. So we have what's called a Bohr model, where we will actually show those electrons in particular rings. So I would like you right now to get out your journal. And on your journal, we're going to do and add to our table of contents electron level notes for your next page. And you are going to go, and after we've already done our atoms, you should have taken pictures of your atomic structure summaries and sent them to me. The next page is going to be electron level notes, and you are going to do some notes and some drawings in here as we go through. So I'm going to hit pause for you to get that set up. Okay, so in your journal, I want you to copy these 4 bullets down, and then we will discuss. Go ahead and hit pause while you copy these in your journal. Okay, as we are doing, drawing our atoms, our first energy level, the one that can be closest to the nucleus in that first ring, can hold no more than 2 electrons. So we know that because of APE, once we know the atomic number, we can figure out the number of electrons we need to put in that atom. So if it has, we're going to fill up that first energy level first with 2. If it has more than 2 electrons, then they're going to spill over into that second level, which can hold 8. So we would then draw 8 electrons in the second level, and if it's one of those bigger atoms that we're drawing, that it has more than 10 electrons, those others will spill over into the third. Now, as we do that, know that there are bigger atoms than, let's say, that have more than 18 electrons. You'll learn about those in high school. So now let's go ahead, and we are going to practice drawing some atoms in our journal. So if you will open your journal back up, let me open this screen so that we can share. If we were to be drawing an atom of B, and you are going to have to hunt and peck on your periodic table and find B, and the capital B is boron. It's atomic number 5, but I'm telling you that it has a mass of 11 atomic mass units. So now remember, with ape, man, if it's atomic, when we find boron, we find that its atomic number is 5. I know that it has an atomic number of 5. That means it's going to have 5 protons and 5 electrons. So I can go write a P here, and for 5 protons, and for 5 electrons, so this is my nucleus. For 5 electrons, remember the first level can hold 2, so I'm going to color in 2 electrons, and that leaves the second level I need to put 3 electrons in. So I need you to draw this in your journal. Now, you don't know neutrons yet, so you've got to use the mass that I've given you here. So the mass is 11, and if I subtract my atomic number, which was 5, here's my atomic number, that's going to give me 6 for neutrons. So that's how I know that I have 6 neutrons. Remember, protons plus neutrons, all of the mass of the atom is in the nucleus. Protons are a positive charge. Neutrons have no charge. Okay, so these are positive charges. So my nucleus has a positive charge because of 5 protons, and my electron cloud has 5 negatives, which keeps it all balanced. The next one we drew in class together is we drew aluminum. So if you go find aluminum, we're going to use have a mass of 27 AMU. So aluminum, if I use APE, aluminum is atomic number 13. So that means there's going to be 13 protons and 13 electrons. So you can go ahead, draw your nucleus, and put 13 protons in there. We'll talk about the neutrons in just a little bit. With the 13 electrons, okay, let's go ahead. I'm going to go to put man so we can figure out our neutrons. So my mass, I've told you over here, was 27. And my atomic number is 13. I'm going to subtract that, and I'm going to get 14 neutrons. So I'll have 14 neutrons there. So I have 13 plus charges, 14 neutral charges. It's a neutral atom, so electrons are the same as protons. I need 13 of them. Only 2 can go in the first level. 8 can go in the second level. 2 plus 8 is 10. That leaves 3 left over to go in the third level. Okay, so once you have those, all we did with the rest of class then is we worked on building models together in class and in a pear deck. So you've got the models there. I want you to work on your Quizlet vocabulary, which is number 4 in your Google Classroom, and then you need to complete your test review before next class, because you do have a test next class period. You're welcome to come to tutoring in the mornings at 8 o'clock, and I'm also available at 2 in the afternoon every afternoon. We'll see you later. Bye.